Welcome. In this video lecture, we will see how we can solve this aggregate production planning problems case study. First of all, we will try to build a math model of this particular scenario, and then we will solve that math problem using IBM ILOG OPL CPLEX Studio. So as you can see in this scenario, we have a basically product family, which is basically a cabinet. Okay, so that is a cabinet manufacturing company, and they have given us the next 12 months sales forecast, or we can say the demand forecast. So in a January, we have given the demand forecast in for the February until the December. Other than that, they have given us the information regarding the planning values regarding the regular production cost. They are telling us the per cabinet cost, over time production cost, so the average monthly inventory holding cost per cabinet. Okay, so the labor hours required to produce one unit of the cabinet, the maximum regular time production capacity. Similarly, they are telling us the allowable overtime production per month, which is basically the 10% of the regular production capacity. Okay, the production quantity basically we are going to take it. Okay, and then our work per month per employee, and then we have the hiring cost per worker. Similarly, we have the layoff cost per worker. In addition to that, they are saying that at the start of this planning we already have 100 cabinets, and we also would like that at the end of this time period we must have the 100 cabinets. Same is the case for the workforce. Initially, we have the 100 workforce, and we would like that at the end of the planning horizon, which means at the end of the December, we must retain this number of workers as 100. So let's discuss how we can build the math model based on this particular scenario. So first of all, our decision variables are going to be inventory in time period T, how much inventory we should have in time period T. That is our first decision variable according to the problem. And then QT is going to be the regular production quantity. Then OT is the overtime production quantity. Okay, so in a overtime, how much quantity we should produce, that is another variable. Then we have how much labor we should hire in a time period T, and then how much labor we should fire in time period T. Okay, and then another decision variable is going to be WT, which is the workforce, which we are going to calculate with the help of hiring and firing. That is how much workforce we should have in a time period T. So these are the decision variables we have, right? So based on that, we are going to build the math model. So as we know that in an aggregate production planning, we are trying to minimizing the total cost. Okay, and the total cost is going to be equal to sum of T from 1 to capital T, that is representing the planning horizon from 1 to capital T. And then the first thing we have, that is a production cost. So CP is representing production cost per unit multiplied by the quantity we are producing in time period T in a regular time, plus overtime production cost plus the quantity we are producing in a overtime. Then plus we have the holding cost. So that is CH is representing holding cost per unit. Okay, multiplied by the IT, the inventory we have in time period T. Then we have the hiring cost. Okay, multiply by the number of persons we have hired in time period T, plus we have the layoff cost. Okay, so layoff, right? So multiply by the number of person we are lay off, which is firing, right? Plus uh, we have all, right? So this is as per the scenario, we have the variables: regular time production quantity, overtime, inventory, hiring, and firing. So this is the total cost we would like to minimize. Subject to, we have the first constraint is, that is the inventory balancing constraint, which is we are saying that the last time period inventory must be equal to the quantity regular time production quantity plus overtime production quantity must be equal to the demand of the time period. Okay, plus we have the inventory at the end of that time period must be for all the time period this constraint should be satisfied. In addition to that, in a scenario, they have informed us that the initial inventory is we have the 100. Okay, and the second they have mentioned us that the time period capital T, which is the 12th time period, because they have given us total 12. Okay, so in a 12th month we must have the inventory of 100, right? So the next constraint we have, that is regarding the regular time production quantity. So this must be less than or equal to the workforce we have in time period T multiplied by, we can say that that is how much unit one worker can produce, that we can calculate based on, so basically every worker is working per month is 160 hours. Okay, and the one cabinet they can produce 20, so that means we are going to calculate 160 divided by 120. Okay, that is basically the number of cabinet a worker can produce, okay, in a month, the number of cabinets. So multiply by the number of workers we have, that is a regular time production quantity for all time period. Then for the overtime production quantity must be less than or equal to the 10% of the regular time production quantity, the quantity we have produced in a regular time for all time period. Okay, and the next constraint we have regarding the basically the workforce level we must have. So that is the workforce we must have in time period T is equal to the workforce we have in a last time period plus how many persons we are hiring in a time period T minus how many workforce we are firing or lay off in time period T for all time period T. In addition to that, they have informed us that the initial workforce we have the 100, and we would like that at the end of the planning horizon, which is the at the end of the 12th month, we must have the 100 workers, right? That is a workforce. So, so this is the set of constraints we have. Okay, the lastly, the IT is the inventory as well as QT is the regular time production quantity, and OT must be greater than or equal to 0, which I am considering as a continuous variable. Whereas the WT, the number of workers, the number of person we are hiring, and the number of person we are lay off or the firing in time period T must be greater than 0 and integer. Okay, so these three variables are integer and positive, so these are continuous, so that's why this is called as a mixed integer linear programming model. So if you want to make to restrict these variables as well as an integer, so then it become a pure integer linear programming model. Now let's discuss how we can implement this math model to solve this particular case study in a OBM CPLEX studio, how we can do that. So first of all, as we can see that we have the 12 time period, that means we need to show the index. Okay, so int capital T is equal to 3 dots. So that means we are mentioning that the total number of time periods are 12. Okay, so that is the planning horizon we have, right? So these are the 12 planning horizons. And then we are trying to tell is that is where it should be started. So the number of periods starting point is 1 to T. So that is we are telling with the help of range. Okay, then periods is equal to 1 to capital T, right? Then we need to mention regarding parameters and data. So the parameters and data, the information we have, that is the first one we have, that is the labor hours per unit. So we are mentioning that how many labor hours we needed to produce one cabinet, which is 20. So that's why we are saying int, that is a keyword. So labor underscore hours per unit is equal to 3 dot pin. We are basically showing how many labor hours needed to produce one unit is equal to, that is basically 20 hours, which is the information they have given us. The next thing is that is how many hours per employee is working. So we are defining int worker hours per month per employee. Okay, that is going to be equal to 160. So using these, basically we can calculate that how many unit each worker can produce in a month, which we can calculate with the help of 160 divided by 20. So we will get the number of units that each worker can produce, which is 8. Okay. Then it is they have given us the information regarding allowable production because that is in a fraction. So that's why I'm using float. Okay, so the value they have given us is basically the 10% of the regular time production quantity. So which is equal to 10%. Okay, so right now, and we will develop a constraint as we have seen earlier. Okay, then they have given us the regular time production cost, overtime production cost data, hiring cost, layoff cost, holding cost, and the demand in each period. So this is basically the regular time production cost. They have given us the 2000. This one is similarly, we have the overtime production cost, right? Then this is the hiring cost, this is the layoff cost, and this is the holding cost per unit, which is 40. Okay, and in order to define the demand, because the demand is varying in every time period, which is basically this one. So for every month, so we need to use array, okay, because this is indicating demand is for the January, then for the February, for the March, and so on. Okay, so once we have declared the parameters and the data, now we need to define the decision variables. So the first decision variable we have, that is the regular time production quantity. Okay, so we are representing with float plus, which means we are saying that it should be greater than or equal to 0. So that means we are considering as a continuous variable. So that is d var is a defined variable. That is a keyword to tell this is the basically a decision variable we have. Another decision variable, this is the overtime production quantity. Again, I am considering continuous. This is the inventory. Okay, so right now remember that over here we are using the basically argument periods because we are saying the time period is starting from 1 to capital T, right? So how many basically boxes we have in a T is that is 12 boxes, because the 12 means we have the 12 time period. But as we know that in an inventory balancing constraint, we also have the T minus one. So that's why we needed basically 13 boxes. So for that, we need to tell how much quantity we have in a initial inventory. So that's why we are, instead of using the periods, so we are using 0 to capital T, because the initial inventory they have already tell us that that is 100. Okay, and then up to T. So that means in an inventory array we have the 13 boxes, and every box has a certain number which is 0, 1 to up to 12. So similarly, we have defining the hiring variable, which I am considering as int plus, because I would like that it must be giving us the number integer number. The layoff must be integer, and another variable we are using, that is a workforce. Okay, and the workforce we have in a time period T, again we are using from 0 to T, as we have seen in our math model. In a workforce, we also have a T minus 1 like in an inventory balancing constraint. So that's why for these two variables, we needed 13 boxes from 0 to 12. For the other decision variable, we only need 12 boxes, right? Okay, the next thing is we have the objective function. We would like to minimizing the total cost, that is from sum t in periods, that is 1 to t. So this is how we are calculating the regular time production cost. So this is basically regular time production cost per unit multiplied by the regular time production quantity in period t. This is overtime production cost. This is the hiring cost. This is the layoff, or you can say firing cost. This is the holding cost we have. Okay, so we would like to minimize this total cost. Then we have subject to the constraints. The first constraint we have, that is the initial constraint. So this is we are giving the label. So constraint initial inventory is equal to inventory in time period 0 must be equal to 100. So inventory in time period 12 must be equal to 100, okay, in the last time period. Or you can also use the capital T over here, okay. So both are fine. So because the capital T is equal to the 12, right? Okay, the next one is we have the inventory balancing concept. So that was the initialization values they have given that we would like the initial inventory is 100, and at the end of planning horizon we must have the inventory level is equal to 100. The next one is we have the inventory balancing constraint. So for all teen periods, that means for all the time periods, so the inventory we have in a last time period must be added in that how much quantity we are producing in period T in a regular time plus overtime production quantity. So this must be equal to the inventory we have at the end of that time period plus the demand we have in that time period. Okay, so this must be equal. So this is called as the inventory balancing constraint, or you can say the demand constraint. The next we are have to apply the regular time production capacity constraint. So for all teen periods, so regular time production quantity must be less than or equal to the workforce we have in time period T. So that is basically indicating the number of workers we have. Multiply by we are calculating with the help of those variable that how many number of unit each worker can produce per month. So that is basically working hours per month per employee, which is 160 divided by this is 20 that was given in that scenario, right? So this is going to be 160 divided by 20 multiplied by the workforce we have in a period T. Okay, that must be the capacity in a regular time production. So this must be the regular time production quantity must be less than or equal to this quantity. And then for the overtime production quantity capacity, we have the overtime production quantity must be less than or equal to the allowable overtime production, which is 10% of the regular time production quantity. So that is basically a capacity constraint for overtime production. Okay. Then we have the workforce constraint. So the workforce we have in time period T must be equal to the workforce we have in a last time period plus the number of person we are hiring in period T minus the number of person we are layoffing or firing in period T. And in addition to that, they have given us the information that the initial workforce we have 100 as well as at the ending of the planning horizon, which means at the end of the December, we must have the 100 workforce must be available. So either you can use the 12 or the capital T, both are fine, right? Now, what we are going to do is we are going to drag and drop this model and data file into the configuration, and then by right clicking on the configuration and run it, we would be able to solve this particular problem. Okay, so we are getting this is the answer, optimum answer we are getting. So if you can see in a solution tab, so this is basically the objective function answer. This is it is indicating in a regular time how much quantity we should produce in January, in February, in March, April, May, till December. This is indicating how much quantity we should produce in a overtime production in a particular month. So this is the indicating how much worker we should hire in January, how much worker we should hire in February, March, and so on. This is regarding the layoff. So this is regarding the inventory. So this is the inventory we have in time period 0. Okay, and then this is the inventory we should have in this particular month, and then these are the inventories. Okay, so this is the initial workforce, this is the ending workforce, similarly kind of inventory, and this is the number of workforce we have during the period February, March, April, and so on, right? So I hope you got the idea like how we can solve this aggregate production planning problem using IBM ILOG OPL CPLEX Studio. So thank you so much. See you in the next video.